The today's menu is the batteries, fuel cells, and corrosion. I will finish this within nearly 15 to 20 minutes. Then we will go for the electrolytic cells or electrolysis, electrolytic cell. The next part of the electrolytic, the second part of the electrolytic cells, and conductivity, then ionic conductometric applications of this conductivity. Three parts would be there in that. And of the three parts, electrolytic cells would be, I think I will finish today's session itself. With that introduction, we will see the first batteries, but no questions so far asked in the batteries. However, it is, let us have a look into this. Sometimes some question may be arising in this. Now you know that what is meant by voltaic cells. A voltaic cell is a cell in which electricity is produced due to the spontaneous redox reaction. Then what is a battery? Battery is nothing but a group of cells, voltaic cells present. The battery army, in the army there's called the battery of man. You know? They will be grouped together, they will be go ahead in front of some other vehicles, etc. They call this the battery. Here also we call this the battery. It is a portable, self-contained electrochemical power supply that consists of, the battery consists of one or more voltaic cells. One or more voltaic cells. Why one or more voltaic cells are required? Because depending upon the nature of the work in which current is required. For example, if you want to start a car or a bike or a scooter, anything would require first initially a voltage should be supplied. Starting with that, then all voltage, other voltage will be produced with the dynamic present in that scooter itself during its running. And for starting a car, 12 volt is initially required. What is the maximum voltage that is produced in a voltaic cell? That is due to the highest oxidation potential. That is lithium and lithium plus ion. It is having 3.05 volt, etc. And the lowest is the fluorine bar fluoride ion, which is having minus 2.46 volt. If you couple these two, one, you would get nearly 5.5 to 5.5 volt. You can generate 5.5 volt from the cell, voltaic cell. But coupling these two processes will lead to very difficult, and environmentally the fluorine is very, very toxic. Therefore, no voltaic cell is constructed using making use of this fluorine maximum potential electrode. Therefore, what is the maximum voltage that can be derived? That voltage, a voltaic cell should be having its electrolyte. There should be conducive to the atmosphere, economically cheap, etc. By making use of this, so far we have achieved the 2.4 volt would be in everywhere it is comfortable to us. But to start a car, you are need of 12 volt. Therefore, in such cases, you have to assemble 6 voltaic cells in series. They will give us to 12 volt. If you want a 4 volt battery, then 2 volt battery will be present in that one, and so on. That depending upon batteries, depending upon the nature of the work through which electricity should be produced, you can make use of either a battery consisting of only one voltaic cell or a number of voltaic cells. And these voltaic cells are classified into the primary voltaic and second is the secondary voltaic. What's the difference between the primary and secondary voltaic? The primary voltaic cell is nothing but the cell so far we have discussed is a primary voltaic cell. In this primary voltaic cell, as time passes, the concentration of the electrode would be going on decreasing. The concentration of the electrode would be the cathode compartment is going on increasing. The concentration of the electrolyte in the anode compartment is going on decreasing, and the cathode mass is going on increasing and so on. Because of the difference in the concentration change according to the non-speed division, the heat is going to be changing. At one particular time, the voltage derived from that cell is becoming zero. That condition, the cell is said to be dead. What is the fact of this? You have to discard that battery because the reactions, the net cell reaction cannot be reversed by applying this one. Therefore, those batteries, those voltaic cells, which cannot be rechargeable by using an external source, are called primary voltaic cells. And what are the primary cells or battery you are using? The dry cells you are using the day by day, every battery or and some depot battery, etc. They are dry cells. We call it as, or sometimes it's the alkaline batteries also. That alkaline batteries, these are all can be of use and through nature. But there are some batteries which can be reversed, which can be recharged and can be reused. Of these, the first and foremost is the lead storage batteries. The lead storage batteries. You know what is the lead storage battery? I am not going to discuss it in lengthier one. In the lead storage battery, the anode is here, lead, and the cathode is here, lead dioxide coated lead. Lead dioxide coated lead. In between this, the common electrolyte present is sulfuric acid. The common electrolyte present is a sulfuric acid. What is the anode reaction that is taking place? The lead in the solid state react with the hydrogen sulfate that is derived from sulfuric acid aqueous and giving lead sulfate, an insoluble solid deposited on the lead. Solid deposited on the lead anode and 4 H plus ion aqueous plus 2 electrons. And in the cathode, we know the cathode reduction is taking place. What happened? The PbO2 solid, the coated lead dioxide, reacts with the HSO4 minus aqueous, which it is in contact, plus 3H plus, which is already present in this. And here not it is 4, it is just H. Sorry, correct it here. Only one H plus because here only hydrogen is present. Here also one hydrogen. 3H plus aqueous plus 2 electron giving lead sulfate is solid. Here also lead sulfate is solid is formed. It is adhering on the cathode and to water liquid. If you consider the overall net reaction, but no question is so far asked. What is the overall cell reaction that is taking place in lead storage battery? You should know this. Lead solid and lead dioxide is solid. Note here, the electrolytes or reactants are both are solid. But so far we have studied in our voltaic cell. One would be the solid, another would be aqueous solution. H minus SO4 aqueous plus 2H plus aqueous giving 2 lead sulfate solid plus 2 water liquid. This is the net cell reaction that is taking place. The voltage for this is here lead sulfide is lead solid is converted to lead sulfate. Therefore, reaction taking place is E naught of lead bar lead sulfate. And another thing that is taking place is the reduction, the lead dioxide is converted into lead sulfate, PbO2 bar, BbSO4. And for this oxidation equation, potential is 0.356 and the reduction potential is 1.685 equal to the value is equal to 2.041 volt. And we normally call the lead storage battery. Each battery would give rise to a 2 volt battery. And in your home, the alternator is there, that would be there when the current is shut off. You are making use of the lead storage battery. Here 6 volt battery would be assembled or 24 volt battery would be assembled depending upon the number of lights to be lit during the shutdown of the electricity, the EB electricity. Okay, therefore the minimum volt derived is the 2. What is the advantage of this one? If you use the Nernst equation, you can see that the product side, lead sulfate is solid, the activity is taken to be 1. The water, it is a liquid, its activity is taken to be 1. By divided by the lead solid, the activity is taken to be 1. Lead dioxide, the activity taken to be 1. Only thing is the concentration of the sulfuric acid. This would give rise to make the cells to deliver the 2 volt energy for a longer period, nearly 4 or 5 years it will be delivered. After the shutting of this shell, you can regenerate, so recharge this battery. And it is the reaction during the recharge is the reverse of this reaction. That is in the reactant side, 2 lead sulfate and 2 water will be present. And the product side, this other thing will be present. And this is a secondary voltage cell. Therefore, what do you mean by secondary voltage cells? The those shares, voltaic cells, which can be regenerated from secondary shells. With this introduction, I finish this batteries. Then I'm going to discuss the fuel cells and the problems have been asked in the fuel cells. What do you mean by fuel cells? Before discovery of these fuel cells, how that fuels are used to generate electricity. You know the function principle of thermal power station. I think so. That is a conventional method we are using. The coal, fuels. The fuels may be carbon or hydrocarbons or hydrogen, etc. Hydrocarbon, hydrogen, etc. They are all used as the fuel. The fuels are burnt in excess of oxygen. They are converted into carbon dioxide and water. Breathing is delta G would be released enormous amount of the keeps the potential to be changed. Making that using that energy, we are boiling the water, converting into steam. The steam is then allowed to pass under pressure over turbine. The turbine is rotating in between the magnet and the electricity is produced, what we have seen in the uh, atomic power plant. There the atomic energy is used, but here the thermal energy used to produce it. In this conventional method, what we have used as the fuel, only 20 to 40% of the effective conversions are there because the reactions taking place are 1 or 2 or 3 or 4 steps. Therefore, in each step, the efficiency is going on decreasing. Therefore, if you calculate the 40% of the carbon used is converted to electrical energy, 60% of the carbon used is really wasted. Under this condition, the fuel cells are developed. In the important fuel cells so far developed is hydrogen oxygen fuel cell, the hydrocarbon oxygen fuel cell, zinc oxygen fuel cell, then carbon coal-fired fuel cells also. Now during coal firing, you are getting carbon monoxide and it burns with oxygen, giving rise to the shells. And I will give only a small discussion with the hydrogen oxygen fuel cell, then I will go for working out the problems in the fuel cells. In the hydrogen oxygen fuel cells, the electrodes are nothing but the graphite. So porous graphite. And here there is a partition between the anode and cathode. And this is the anode. Here anode is nothing but the perforated carbon. And it is partitioning this one. And here it is an anode graphite. Cathode is also a perforated graphite, and through which this hydrogen is passed at 50 atmospheric pressure and oxygen is passed through the cathode at the same pressure 50 atmosphere. In between these two, alkali would be present. Either it may be concentrated potassium hydroxide or concentrated sodium hydroxide. What happened? What is the cell reaction that is taking place? In the anode reaction, hydrogen is passing through the perforated. This is a gel, potassium hydroxide gel solution would be there. Therefore, due to the perforation, hydrogen, the anode compartment, is undergoing oxidation to give H plus and electron. The H plus ion immediately combines with the OH, the alkaline present in the nearby anode is converted to water. Therefore, what is the anode reaction that is taking place? H2H plus cancel. Hydrogen reacts with the 2OH minus, giving H2O, 2H2O plus 2 electron. Plus, am I correct? Yeah, here we have to put 2OH and here you have to balance 2. Therefore, 2 electrons. This is the reaction that is taking place in the anode. What is the reaction that is taking place at the cathode? Cathode, oxygen is undergoing reduction in the taking the electron from the solution produced in the anode. 4 electrons is there in presence of water that undergoes reduction to produce back the OH, the alkali, OH minus, 4OH minus. Therefore, what is this is the cathode reaction that is taking place. What is the net cell reaction that is taking place? Add these two 1. Add these two 1. And you will get the net reaction as 2H2 gas reacting with O2 gas giving 2H2O liquid. This is the net reaction that is taking place. If you add this to anode reaction and cathode reaction, you will end up with this. And similarly, if you use a hydrocarbon and oxygen fuel cell, you will be having the hydrocarbon as another reactant and oxygen another reactant and giving rise to carbon dioxide and water. The hydrocarbon may be a propane, butane, pentane, or mixture of all these things. Hydrocarbon. In zinc air fuel cell or zinc oxidation fuel cell, what would be the net product that would be obtained? Zinc of the solid plus oxygen gas giving rise to zinc oxide solid. After converting here, the cell efficiency is found to be 75%. And similarly, coal fired with oxygen, the efficiency is found to be 60%. But in the conventional, we are having the efficiency 20 to 40%. And in the coal-fired fuel cell, it is found to be 60%. And so much research is going on in this field. The first area of research in the material sciences, lithium ion battery. It is a rechargeable battery, that is secondary batteries. Here research is going on. If anybody wants to do research after getting the JRF, you would probably prefer the lithium ion battery because this is a first area going on in the material research. To increasing the efficiency of this uh, fuel cells is a predominant task at the person because conventional energy source would be in due course it will be not possible. You have to find out lithium ion battery and solar energy batteries. So the solar energy battery also at person you are having 20% maximum efficiency. What the energy will derive from the sun is not 100% converted into electrical energy. Therefore, how to improve the efficiency of the cell? It is a test area, it's an ongoing process. Okay, and what is the efficiency of this fuel cell? How would you calculate the efficiency? That can be done by making use of this equation. Delta G is equal to eta is equal to delta G by delta H, where eta is nothing but the efficiency of the fuel cell. And what is the voltage that would be derived from that fuel cell, for which you should make use of this equation? Delta G is equal to minus NFE. This is the E is the voltage of the fuel cell under unnormal or non-standard condition. You can make use of this, for which you should know how many electrons are involved in the fuel cell reaction, net reaction, and what is the energy involved released during this fuel cell reaction, delta G. If you know this, you can calculate E. If you know you are given delta G and delta H, you can calculate the efficiency of this. Or efficiency is given, delta G is given, you may be asked to calculate delta H or the other words. Or the eta efficiency can be also related to the cell voltage as minus NFE by delta H. Therefore, if you are given the delta H and the efficiency, you can calculate the E also. But depending upon the problem asked, you can make use of this type of equation. All these equations you know what is a fresh equation you have studied. The eta efficiency is equal to delta G by delta I, for which the number of electrons involved in the process should be furnished. Now you are given, suppose you are given this net fuel cell reaction. Is it possible to find out how many electrons are involved in that process? It is easier. I have already told you how to calculate the net reaction. Take either the species undergoing oxidation alone or take either the species undergoing reduction. You can calculate. Now, let us forget this stepwise calculation. From the step, you can say that is 2 electrons are involved in this one. That can be easily calculated here. How? By making use of this one. which reactions you are going to make use of this. Take oxygen. How many electrons are involved in the process? H2 to H2O. Okay. Two minus. And how find out? You can take which is undergoing oxidation. Hydrogen here is zero state. Hydrogen in the water it is plus one. How many charges, total charges are taken altogether? The stoichiometric ratio you should find out. 4 plus is that. Here how many charges are present? Zero is that. Therefore, how many electrons are involved in the process? 4 electrons are involved. You can easily calculate this. Similarly, or you can take the species undergoing reduction, oxygen is undergoing reduction. Here, the oxidation state of oxygen is 2 minus. Here, oxidation state of oxygen is 0. For one atom, it is 0. For two atom, it is 0. Therefore, in the reactant side, it is 0. In the product, for one atom, 2 minus. And look at the stoichiometry, 2 oxygen atom, 4 minus. Therefore, 4 electrons are consumed by the oxygen. Therefore, total number of electrons involved is 4. This is the n value. Knowing the n value, therefore, n value may be given or may not be given. But if it is given, it's well and good. If it is not given, don't be confused. You can calculate the value. Now I'm going to give the problem that is asked in the year 2014. They have given the electrons involved in that process, but I'm not going to give you the electrons involved in the process. Automatically, we are going for the calculation only. Take down the problems. Fuel cells provide clean electrical energy. Clean electrical energy. I think so because I am thinking that they are giving nearly 4 or 5 lines which are irrelevant to our problem. Just they are diverting your attention. I think it is not necessary to give and waste our time. We can take the question in this way. If we use butane instead of hydrogen at 1 bar, instead of hydrogen at 1 bar and 298 degree Kelvin, the following hydrocarbon oxygen fuel shell reaction occurs. C4H10. We are in need of only this one, not the 2 or 3 sentences which are irrelevant to the problem. 13/2 O2 gas giving 4 CO2 gas plus 5H2O liquid. If the change in the Gibbs free energy, change in the Gibbs free energy of this reaction is 2746.06 kilojoule per mole, comma, involving dash number of electrons. Okay. How many electrons are involved in the process? They have given, but I have omitted these because it's not necessary. Comma. Its open circuit voltages. Option A 1.55 volt. Option B 1.09 volt. C 3.15 volt. D 2.06 volt. And whatever free energy change is given, therefore the formula to be used is delta G is equal to minus NF E. Here the delta G Here, just they will say only the free energy change. Here, this is burning of this hydrocarbon. Definitely, energy is released. It's a exothermic reaction. In thermochemistry, for the combustion of any material, they won't give the value in terms of negative value. You know this because combustion means burning. During burning, heat energy is released. Therefore, here also, the free energy change is a minus value. Therefore, you should put -2746. Here the G is given in terms of 1 joule per coulombs, we know. Therefore, delta G should be in joules, but given is kilojoules. Therefore, convert into a joule, 6 joules is equal to minus n number of electrons involved in the fuel cell reaction. In the problem, they have already given so many number of electrons are involved, but I have purposely omitted this because you can find out the number of electrons in this. And E is asked here, what is this? Anybody, what is the number of electrons involved in the fuel cell reaction? Anybody? Anybody? Anybody, what is the number of electrons involved in the process? Here, don't take the hydrocarbon C4-H10. It is better to take the oxygen and how it's a reduction process, how many electrons are involved in the reduction process. First, to find out how many oxygen atoms are here. Here, if you find out 13 oxygen atoms are there, each would be having 0 oxidation state for 0 in the reactant side. And how many oxygen atoms are there? Here, 2 oxygen atoms, each would be having 2 minus charge. Therefore, 8 into 2 minus charge equal to minus 16. In the other, and each oxygen is having this one. How many oxygen atoms are there? 10. 5. 5 into 2 minus 10. Therefore, altogether, how many electrons are present here? 26 electrons are consumed. That is, oxygen 0 state to converted to oxygen. Totally 13 oxygen in 0 state is converted into 13 oxygen in the 2 minus, that is equal to 26 electrons. And in the question, they have given it as 26 electrons. But you should have the practice of calculating the electrons also. Therefore, I have omitted this. And put and find out what is the value, correct value. Put it and find out the values. Correct value. What is the correct value? Is it a very tedious problem? The multiplication and division I have already
1.09.
1.09 is the correct answer. Do the calculation using your calculation method. Use your calculator. Though it is given such a large number, here also charge a number and 26. It can be made simplified. How? This can be written as E is asked. E is equal to 2746060 divided by 26 into 96500 and use our method 2.7 into 1, 2, 3, 4, 5, 6 into 10 power 6 divided by 2.6 into 9 into 10 power 1 into 9.7 into 1, 2, 3, 4 into 10 power 4. Therefore, equal to this 10 power 1, 10 power 5, 2.7, this and this cancel. And 1 divided by 9.7. 1 divided by 9.7 into 10 power 1 Or you can simply take it as 10 and it is equal to point, not 1 into 10, I'm sorry, point 0.1 into 10. That is, your answer should be nearing to, what is the correct answer? 1.01. Yeah. So far, you are not making use of your calculator, I think so. Therefore, you are hesitating giving the answer to us. Okay, then it is your soup. It is not my soup. You have to increase your efficiency of your calculator. Take down the questions as a homework. Efficiency of the hydrogen oxygen fuel cell. Hydrogen oxygen fuel cell will be will be within the bracket. Write down this, given delta G naught is equal to minus 237.4 kilojoule per mole, and delta H naught is equal to minus 285.5 kilojoules per mole. Close the bracket. Option A, 53.12%. A percentage is given, but the efficiency eta, your calculator would be a fraction, multiply with 100, you will get the percentage. 83.12, C, 63.12, D, 80. Check your answer. Take down the next question. This is for your homework. Take down the next question. Hydrogen oxygen fuel cell. Hydrogen oxygen fuel cell. In the hydrogen oxygen fuel cell, 6.72 liter of hydrogen at standard temperature and pressure react. Standard temperature and pressure react in 16 minutes and 5 seconds. 16 minutes and 5 seconds. The average current produced in ampere, within bracket in ampere, is A 1.3, B 300, C 600, D 16. 16. So this problem is not related to our at this present, because this involves the ampere and this one. These are concerned with, but it is given the fuel cell, but the data given are all with respect to the electrolysis process, electrolytic process. Therefore, keep this problem here, but we will work out after seeing the electrolysis cell, electrolytic cells. We will definitely work out this. If I forgot, please remember me. Okay, remind me. Okay, with this I finished this one. And the last one is the corrosion. And what is mean by corrosion? The conversion. What do you mean by corrosion? No questions so far asked. But I will tell you only one thing. What do you mean by corrosion? The conversion of a metal sulfate coated with either oxide, carbonate, or any other thing, sulfide, etc., are said to be corroded. And you know the silverware present in your home, if you expose it to the atmosphere here, it will be blocked. It is also a corrosion, which is adhering over the silverware. The sulfide present in the atmosphere air reacts with the silver forming silver sulfide. Not oxygen is not going to react with this, but at the same time, if you have an aluminum utensils, the weight batches would be there here. Aluminum oxide would be coated. Iron, oxygen would be immediately reacting with the iron forming iron oxide. We call it as the rusting of iron. Similarly, copper. and a green color material will be formed on the copper utensils. That is due to the formation of basic carbonate. Therefore, these are all said to be a corrosion. Rusting is the specific name given to the corrosion of the iron with the oxygen. And how to prevent this corrosion? To prevent the corrosion, various techniques are there, galvanization or painting, making oil or applying grease and so on. They are making use of this. And one method is galvanization. That is, what do you mean by galvanization? That material which surface should be protected should be coated with more electropositive, more electropositive batteries. That surface we call it as they call the sacrificial protection. We call this the sacrificial protection or electrical protection. Sorry, sacrificial protection is the correct word. For one question, please take down the one question and you can give the answer for this. Sacrificial protection of iron. Sacrificial protection of iron is provided by the metals like option A, silver, aluminium, option B, copper, zinc, copper and the next option C, zinc, magnesium, D, all the above. And which metal can be used as a sacrificial protection or galvanization? We have already given the oxidation potential value, E naught of oxidation potential value. We started from lithium, sodium, potassium. Here the oxidation potential is going on decreasing. And which metal you are going to protect? For example, iron is present here, copper here, copper kila yaar irukka? Copper kila chapan படிச்சிருப்பீங்களே. Next is the mercury. அதுக்கு அடுத்தது யார் இருக்கா? Silver.
Silver,
அடுத்தது platinum.
platinum, gold.
This is the gold. And if you want to protect the copper, what is the sacrificial protection that can be applied? Those metals present above the copper in this electro-oxidation potential can be used as a sacrifice protection. And those metals which are placed below this cannot be used as the sacrificial protection. That is the simplest technique. Therefore, now if you see this, and here you are going to protect iron. Iron is present here. Which metals cannot be used as a sacrificing? Those metals which are placed below the iron in the electrode potential, oxidation potential series cannot be used as this. Therefore, above the iron, which metals are present? Here it is given silver and aluminium. Aluminium is present, silver is placed below the iron, therefore it cannot be used. And then copper and zinc. Zinc is present above the iron, but copper is placed here below this. Therefore, copper cannot be used. Zinc and magnesium, definitely both are placed in above the iron in this one. Therefore, go and look at into the oxidation potential value, which metal is to be protected, and you can what metals can be used as a sacrificing protection. The end metal of considerable, which metal is to be considered? All the above metals, the metals placed above that metals can be used as a sacrificing counter protectors, and below they cannot be used. That is the simplest way. And if at all any question is asked, please answer the question accordingly. With that one, we finish the first part of the electrochemistry. Now we go for the second part of the electrochemistry, that electrolytic shells. Electrolytic shells. First, we will going to see what is meant by electrolytic cells, and we are going to what are the formula what are the formula to be kept in our mind to do problems, and what are the things to concepts to be studied here. Here we are first we are going to see the electrolysis process. Then we are going to see the conductivity of ions, the conductance. Then we are going to see the ionic mobility, and the last application is conductometric titrations. Okay, first we'll start the electrolytic shells. What is the difference between the voltaic cell and electrolytic cells? In voltaic cell, the spontaneous redox reaction is taking place. In the electrolytic cells, they are non-spontaneous. The reverse of that reaction is taking place. Electrolytic cells. As in these voltaic cells, two electrodes are necessary. Here also, two electrodes are necessary to supply electricity from outsource to into the solution. Therefore, two electrode is necessary. And in that voltaic cell, in the voltaic cell, we are generating electricity, and we see it through the voltmeter. But here there is a volt supply should be there. The current voltage supplier should be there. Voltage supplier should be there. And here electron is getting inside this and from the voltage supply. And here electron is moving this. Here once again it is called as anode, and here it is cathode. And there is a difference in the charge of the anode and cathode. The shell or the not shell, it is called the electrode contact. The electrode through which the electron is getting into the cell, it is negatively charged one. And going outside is called the positively charged one. And here these electrodes are smeared with a negative charge electron. And here no electron is now present here, only positive charges. Therefore, these two electrodes are kept in only one kind of the electrode. In electrolytic cell, two electrodes are kept in the two different electrolyte. If it is kept in only one electrolyte, we call it as the electrode concentration shell. But here it is kept in only one electrolytes. And when you pass current from outsource, this electrode would be smeared with the electron supplied from outside. Therefore, it is negatively charged. Since it is smeared with the negative charge, and the ions here, cations and anions are present in the electrolytes, the cations are all attracted by that negative charge, and the cations are moving towards this the electrode having negative charge. And that negative charge electrode, we call it as the cathode. Therefore, cathode here in electrolytic shell is negatively charged. We name this as cathode because cations are attracted by that cell. And consequently, the other electrode, which is positively charged, and here it is named as anode because anions are moving towards that one. Okay, and after the cathode approachment of the plus ion in the cathode, what happened? That plus ion would take the necessary electrons and it is converted into the compound. And which is taking place, which process is taking place in the cathode? Again, reduction is taking place. In the voltaic cell also, production is taking place. Here in the cathode also, reduction is taking place. Therefore, we call it as the cathodic reduction. This process we call it as the cathodic reduction. Then which process would be taking place here? The anions are moving towards this. The anions are there. They release the electron and it is becoming oxidized. These electrons are moving from these two to this. Thus, the shell, the electrical circuit is completed. Here, oxidation takes place. Therefore, we call it as the anodic oxidation. In the voltaic cell also, which a process is taking place in the anode, oxidation, anodic oxidation and cathodic oxidation reduction. And what's the difference between these? Only one electrolyte is in the same electrolyte, these two are kept these. And during the and the process of converting a cation into a uh, metal and the anion into a neutral species, thus a chemical reaction is said to be taking place by the passage of electricity. This process is called electrolysis. That is whenever reaction is initiated by water, by its ion, H plus and OH minus ion. We call this the hydrolysis. Here is making use of the electron. Here the reactions are initiated, therefore it is called electrolysis. Here electron is acting as one of the reagent. In hydrolysis, for example, ferric chloride, when dissolving the ferric chloride in water without adding acid, ferric chloride immediately would be hydrolyzed to give ferric hydroxide and HCl would be formed. That is converted into H plus and OH minus. It is merely a solvent. And the H plus would be reacting with this anion, this would be reacting with this anion, and you will be getting a turbidity will be there. So is the case with the preparation of the standard ferrous ammonium sulfate. You are adding acid. Why? What is the necessity? To avoid the hydrolysis of the ferrous sulfate using the water. If the ions present in the water is assisting that reaction, we call it as a hydrolysis. If ammonia, the ions present in ammonia in non-aqueous medium is assisting the reaction, it is called ammonolysis. And here electrons present in this electric current is assisting the reaction. Therefore, we call it as the electrolysis. And the system with the two electrodes and one electrolyte in which chemical reactions takes place due to the passage of electricity is called electrolytic cell. Therefore, what is electrolytic cell? What is voltaic cell? You can easily define this. Here also two electrode, there also two electrode. One is the anode, another is the cathode. Again, say cathode is negatively charged in electrolytic cell, anode is positively charged. The charge is entirely different. Here, what is the process that is taking place in electrolytic cell? Cathodic reduction and anodic oxidation. Same is taking place there. Therefore, you can compare like this and this electrolytic cell. What's the difference? And here we call this as the conductors, metallic conductor. Inside the solution, which is conducting the electricity from outsource, that is voltage supplier, the electrons are transferred to the current is transferred to the metal by the passage of electron. But inside the solution, the electron is not carrying the current. It is the ion which is carrying the current. It is the positive ion or negative ions they are carrying. And here these are called the ionic conductor or electrolytic conductor. Electrolytic conductor. Whereas the solid metals, they are all called metallic conductor. What are the difference between the metallic conductor and the electrolytic conductor? I think you have studied in your younger group itself, that is 10th standard or 11th standard. And if not understand these are, I don't know, these are, go and refer some books. What's the difference between the metallic conductor and the ionic conductor? Okay, next step we are going to see is the preferential preferential discharge potential theory. Discharge potential theory. Here, in this electrolytic cell, let us assume we are having anode and cathode. Around the cathode, cations are all present, and cathodic reduction is going to be taking place. Around the anode, anions are present, and the anodes are getting oxidation here. This is what we are expecting. If, for example, sodium chloride is fused sodium chloride, the fused sodium chloride, you consider which ions would be there, sodium ion and the chloride ion. Around the anode cathode, only sodium ion would be taking place. Around the cathode, only chloride ion is present. They are going to be depositing, or the gas is evolved in the corresponding electrode, pertinent electrode. On the other hand, if more than one type of ions are present, either in the cathode side or in the anode side. For example, chloride ion and OH minus ions are present in the anode side. And in the cathode side, sodium ion and potassium ions are present, or aluminum ion and zinc ions are present. Which metal would be first undergoing reduction? Whether both the metals are undergoing reduction simultaneously, or zinc ion first, then aluminum ion, or aluminum ion first, then zinc ion, which will be easily undergoing reduction there. And for which the answer given is by the preferential discharge potential theory. According to this theory, when two or more types of ions are attracted towards an electrode, two or more types of ions are attracted towards the electrode. Ions with lowest discharge potential, is preferentially discharged at that electrode. This is the potential theory, this differential discharge potential theory. Here, in the anode section, oxidation should be taking place. Therefore, which species is having less oxidation potential? Which is having less discharge potential? That would be easily undergoing oxidation. And the cathode section, the cation is to be going to be discharged. Therefore, which is having lower negative reduction potential would be undergoing reduction first. Lower negative reduction potential would be undergoing discharge. Or I can give it, you can make a use of this statement using the oxidation potential, really, what we have studied in there. Or you can make use of the series I am going to give now. For the cations, the discharge potential order is for the cation, the discharge. And what is present in the topmost oxidation potential is having, it will be least discharge, or it is having high discharge potential. What is present in the top of the oxidation potential series we have seen in our electrolytic cell would be, that is, you can take lithium plus ion. It would be very difficult to deposit or remove. Then potassium, then decreasing order, calcium, magnesium. This is a decreasing discharge potential. Then aluminium 3+, zinc 2+, then hydrogen plus next. Hydrogen chelator metals. What are the metals present? Copper 2 plus next. Silver next. Gold. So mercury.
Sir, Mercury,
As a
sir.
mercury, you can make use of. I am not giving the full series. I have not given this one. And gold 3 plus. Therefore, of these metal ion series, the gold 3 plus is having least discharge potential. When all these ions are present, the what I have given in the board, what ion, if at all these ions are present, and which is having least discharge potential, gold 3 plus is having least discharge potential, and it will first undergo reduction, which will be discharged, the ions would be neutralized. 3 plus ion combines with the 3 electrons, giving Au0 state. Next, after complete discharging of Au3 plus, if you increase the potential, slightly increase, then it would discharge Ag plus. You should not, for example, the Ag plus, it is sufficient to give minus 2.8 volt. And 2.8 volt, if is given, it is like this one, minus 2.8. And it is having plus 3.8 volt. Let us assume when you increase the 3.8 volt, suddenly if you give the 3.8 volt from these to these ions, that from calcium to the other ions, it will be immediately deposited. Therefore, each ion should be deposited one by one. You should start with a minimum discharge potential sufficient to discharge only for the gold 3 plus. After complete discharge of this Au plus, you slightly increase the potential so that it is suitable to discharge Ag plus and so on. This is the electrolytic process principle by which the ions are all separated. And similarly, you are having another series for the anions. And the descending order of the discharge potential once again. If sulfate ion is present, it is require higher discharge potential. Next is the nitrate. Next is the OH minus ion. Next is the chloride ion. Then bromide ion and iodide ion. Therefore, if you have the look into this, of these three ions are present, chloride, bromide, iodide, which will be easily discharged, and the iodide will be easily discharged first, and then bromide, and then chloride. In our oxidation potential value, iodide at the top, then bromide, then chloride, least is the fluoride. Here I have not mentioned the fluoride. And if you go for this is the least, then next highest one, and so on. Its oxidation potential is very, very higher. Therefore, least oxidation potential is easily this one. Okay. And you keep it in mind, but I think no question will be asked. But question will be asked in the JAM NEET examination or JAM, not for CSI or examination. Okay, this is a preferential discharge potential theory. Now, let us have an idea. A H plus ion and zinc ion are present. Or I will give you one specific example. And you should be able to answer this question. Sodium chloride is aqueous solution of sodium hydride is hydrolyzed using platinum electrode. Using platinum electrode. That is, a platinum electrode is a dip. Platinum electrode is dipped in the sodium chloride aqueous solution. Okay, sodium chloride aqueous solution. Platinum electrode, platinum electrode. This is the cathode, this is the anode. In the same electrode, we are using the same electrode, but fused sodium chloride. Fused sodium chloride. When you use fused sodium chloride, no problem. Which problem? Around the cathode, only sodium ion will be present. And around the anode, only chloride is present. But when you use aqueous sodium chloride, a problem is rising. Sodium chloride undergoing ionization to Na plus and Cl minus. And water present, it is also undergoing oxidation, sorry, undergoing dissociation due H plus and OH minus. Though the concentration is small, H plus and OH is there. Therefore, how many kinds of cations would be around the cathode and how many kinds of anode anions are present around the anode? Tell me anybody. Tell me anybody. Hello. Around the cathode, cations should be there. What are the cations present in the aqueous solution? Na plus and H plus. They are approaching this anode, which would be first discharging on the cathode, for which we are made of the preferential discharging.
H plus.
Therefore,
Sodium. H plus.
no sodium. H plus is having
H plus, sir.
H plus.
H plus having least
Therefore, H plus electron, which is evolved at the cathode. Sodium is not evolved at the cathode, other than which is evolved at the cathode. Hydrogen is evolved. And in the anode side, what are the anions present? Cl minus and OH minus. Has H plus and which should be evolving in the anode side. Compare the
Chloride.
discharge potential of Cl and chlorine gas would be evolved. Therefore, whenever you electrolyze the aqueous sodium chloride, you will be having hydrogen at the cathode and chlorine at the anode. On the other hand, if you use fused sodium chloride, what are the products of time? What are the products of time? Tell me. Tell me. Only one kind of ion is present. Sodium ions, chloride ion. Therefore, when you electrolyze a fused sodium chloride, you will be getting sodium metal in the cathode and chlorine gas evolved at the anode. But if you are using aqueous, this one. Why there is a difference? Because of the difference in the preferential discharge potential. And making use of this potential theory, discharge potential theory, you can guess what is the product obtained in the cathode, what is the product obtained in the anode, provided the electrode used is an inactive electrode, inert electrode. Here, so far we have discussed the electrode used is a platinum electrode. What do you mean by inert electrode or inactive electrode? Inert electrode is one which is not undergoing reaction with the electrolyte is called inert electrode. Platinum will not undergo any reaction with that electrolyte ion, that is cation or the anions present. Just gas would be evolved or metal would be deposited. It is not undergoing. It is acting as just a electrical contact surface. But there is called the active electrode. This is already we have studied in the electron, the voltaic cell also. And in the active electrode are those which in undergoing reaction with the electrolytes present in the electrolytic shell. We will look up this one example for that and one example for this. Then we will wind up with this preferential discharge potential theory. But you should have an idea about which would be preferentially this one, or which is first, which is second, or can you arrange this anions discharging on this one and cations discharging on this cathode, or which that question, for answering such a question, the series is very, very essential. Okay, in the sodium chloride electrolysis using platinum electrode, here which is depositing H plus hydrogen gas is evolved at the cathode. Therefore, what happened to the OH minus ion in the solution? Next question. Just imagine what happened, what are the decreasing in that side. In one side, hydrogen is H plus ion is going on, converted into hydrogen. The another electrode, Cl minus is going on, converted into Cl minus ion. Therefore, which concentration is going on increasing? Initial, the Na plus is remaining as such. And the other side, as H plus ion is removed from the equilibrium reaction, more and more of OH minus ion is released. Therefore, after certain time, when you start this electrolysis at about pH 7, that is neutral pH 7, after certain time, what about the pH of these electrolytic cells and electrolytes in the electrolytic cell? Whether the pH is remaining 7 or it is greater than 7 or it is less than 7. Anybody answer this question? It is greater than 7
OH minus is present.
because the OH minus ion concentration is going on increase. Your answer is correct. Now I am going to give another question, the same one, but you should give the answer easily. Take copper sulfate aqueous solution. Copper sulfate aqueous solution. You are using platinum electrode. Electrolysis is done. Okay. Electrolysis is done. What is the product? The nature of the species, liberating at anode, liberating at cathode. What about the pH of the solution? எங்க ஆன்சர் பண்ணுங்க பார்க்கலாம். What about the pH of the solution as electrolysis going on?
So cathode copper 2 plus.
Cathode copper 2 plus. Your answer is correct. Why? How you will tell it's copper 2 plus? Because around the cathode copper ion and yes,
Anode
tell me that.
H plus, sir. H
Anode
plus,
plus
sir.
sulfate ion.
Right, okay. Briefly explain the answer also.
Hydrogen copper 2 plus வந்து reduction potential கம்மி சார்.
Discharge potential is small.
I see.
Okay, correct. Therefore, it will be preferentially discharged. Therefore, in this, copper would be liberated at the cathode. Okay, then the anode side.
At anode OH minus is a
OH minus is converted to what? Take down the equation. Here OH minus ion and sulfate ion would be present. And compare the discharge potential. It is having lower discharge, therefore it will be undergoing reduction. Oxidation. OH minus ion undergoing oxidation to give 2 water plus O2 and 4 electrons are released. Here, what is released in the anode side? Oxygen is evolved. What is the difference? Pathingla sodium chloride electrolysis, a different product, copper sulfate electrolysis in another way. And what happened to the pH of the solution? Anybody? pH of the solution.
H plus அதிகமா இருக்கு சார். Therefore, it is
H plus ion is going on, increasing, therefore pH is going on. pH is going on, decreasing.
decreases. So
Yeah, you are correct. Now I am going to use an active electrode. If active electrode is present, what is taking place? அதையும் பார்த்துட்டோம்னா, now you will be well versed with the electrolysis process. Then only problem is to be done. That is very easy to carry out the problem. And now let us consider An active electrode. What is meant by an active electrode? Tell me what is meant by an active electrode?
It will involve in the reaction with the electrolyte.
React with the reacting with the electrolytes.
Sir,
அதை நம்ம இப்ப பார்க்க போறோம். Let us consider. Yeah.
சார் இந்த டிஸ்சார்ஜ் பொட்டன்ஷியல் சொன்னீங்களே சார்,
Yeah.
அதுக்கும் மொபைலிட்டிக்கும் ஏதாவது ரிலேஷன் இருக்குமா சார்?
Discharge potential. Why it is having less discharge potential? நம்ம அங்க ஏன் the discharge potential can be correlated with the redox potential. What we have studied. அங்க மொபிலிட்டிக்கும் அதுக்குமா இருந்தது. The nature of the ions present. அங்க என்னென்ன ப்ராசஸ் நடக்குது? What are the process that is taking place? Conductivity-க்கும் mobility-க்கும் தான் relation இருக்கு. It depends upon to what extent the ions can be, that electrons can be removed from the, or electrons can be added. Removed, I am talking in the voltaics. For example, zinc, giving zinc 2 plus and 2 electron. Here, what is the maximum energy involved in the process is that the 2 electrons should be removed from the zinc ion. What is the force operating between this zinc nucleus and the 2 electrons which is present with that? From the beginning, I have given the lithium ion should be lower potential than the sodium ion, but it is having higher potential. Why? அதுக்கு அப்பயே நான் என்ன சொன்னேன், depends upon the ionic mobility as well as the number energy required to remove an electron, snatch an electron from that neutral species. எல்லாமே cumulative effect. எல்லாம் சேர்ந்து தான் நம்ம சொல்ல முடியும். And this is the only effect that is operative. We can't tell this one. அந்த உள்ள redox potential, what you have studied, here just reverse this one. அவ்வளவுதான். Here adding 1 electron very easier, then that will be easily undergoing reduction. Here adding or removing electrons from the species is easier, it will be easily undergoing this one. That is the discharge potential. If at all there is a change in the order, that will be explained based upon the ionic mobility, which will depends upon the solvent atmosphere present around the species. Okay.
Okay, sir. Thank you, sir.
Next, now I am going to consider active electrode electrolysis of nickel sulfate. One minute. Or electrolysis of silver nitrate using silver, or electrolysis of copper sulfate using copper electrode. Is copper electrode dipped in copper sulfate? Is a active electrode because it is undergoing reaction with the copper sulfate ion. How is it undergoing reaction? We will see it shortly. And for this one, we will consider this one. First, we will take copper sulfate. One is the cathode is the platinum electrode or copper electrode, or anything you can take, and the anode is the copper electrode. Both of them copper electrode, or both of them platinum electrode, or both of them. One is the copper, another is the platinum. In which case copper is there and which case platinum is there. And one secret is the preferential potential, discharge potential theory is applicable only for the inert electrode, not for active electrodes. Not for active electrode. Therefore, what would be taking place when an active electrode is there? அதைத்தான் இப்போ நம்ம என்ன செய்ய போறோம், பார்க்க போறோம். பார்த்துட்டோம்னா now you will be having an idea about the electrolysis, making use of the active electrode. And here, as usual, platinum is there, and it is nearing to this copper ion, and H plus ions would be there. The discharge potential of the copper ion is less. The copper ion is less. Therefore, copper would be preferentially deposited on the platinum. Okay, therefore, what is the cathode reaction that is taking place? Copper 2 plus taking 2 electrons from the cathode forming copper deposited. And here copper electrode, what are the ions present? Copper is a sulfate ion as well as OH minus ions are taking place. Sulfate ion and OH minus ions are taking place. In addition to this, copper 2 plus ion and H plus ions are also present. Here in anode, should be taking place? In anode, which should be taking place? Anodic oxidation. And here I have to mention water is also present. Copper 2 plus ion, sulfate ion, inert electrolyte, and anions, then cations, these are all present around the copper. Here, inert, this preferential discharge theory is applicable only for the inert electrolyte. For reactive copper electrolyte, it is not applicable. Therefore, you have to consider what are the species present around this. And here, what happened is, in the preferential theory of this, the copper is easily undergoing oxidation. Copper is easily undergoing oxidation to give copper ion. Or copper would react with copper sulfate, that is copper 2 plus and so-called copper sulfate, giving, or இப்படி சொல்லிடலாம், copper sulfate சொல்றதுக்கு copper plus sulfate ion would be undergoing reactive activity, forming copper sulfate and plus 2 electrons are formed. So what is taking place? Sulfate ion is present, OH minus ion is present. Here, anything should be undergoing oxidation means this copper 2 plus ion, H plus ion would not be undergoing further oxidation because copper 2 plus to copper 3 plus it would not be taking place. Because in anode, what should be taking place? Anodic oxidation. Therefore, which species can alone be undergoing oxidation? Water, sulfate, and OH minus ion. You have to consider the water also. And of these species, if you use the preferential discharge, OH should be undergoing discharge. But here the reactive electrode is a reactive electrode. It won't undergo reaction with the hydroxide. It undergo reaction with the sulfate ion, forming this one. Copper in the zero state, immediately undergoing reaction with this, giving copper sulfate. And oxidation is taking place. Which is undergoing oxidation? Sulfate is not undergoing oxidation. The copper zero state is undergoing oxidation. Therefore, sulfate is remaining as such. If you know this is the anodic oxidation, this is cathodic reduction. If you, then this and this cancel, 2 electron cancel. And here copper 2 plus cancel. Sulfate and sulfate is taking place. And net reaction, for our purpose, we call it as net reaction is 0. But this is not the case. Here, what is the net reaction? Copper is converted into copper 2 plus. And this copper 2 plus is moving towards the cathode where it is deposited as copper. A mass transfer is taking place. Whenever you use the active electrode, the anode is going on decreasing in its weight and the cathode weight is going on increasing. And the electrolyte concentration is remaining the same. On the other hand, when you use the inert electrode, the electrolyte concentration is going on decreasing. But when you use the active electrode as the anode, the electrolyte concentration remains the constant. Instead, this electrode mass is going to be changed. This is the difference between when you use the inert electrode as well as the active electrode. But I think no question would be asked here. Then with that introduction, we are going to look after into the electrolysis process. The electrolysis process, two laws, the important laws used is the Faraday's laws. And the Faraday's laws, what are the two laws? I don't know, you know very well than me. But I know the last problem, that is formula that we use in calculating problem, the electrolytic processes, Faraday's law. Combining these two laws, we are ending with one equation. W is equal to equivalent weight of the substance divided by the Faraday into 9,000. I'm sorry, into I. I is the strength of the current used for electrolysis. I, it is always given, strength of the current is given in ampere. Amount of the current is different from strength of the current. I'm going to explain this. I is called the strength of the current. T is equal to the time of passage of current. I should be in ampere. F would be in coulombs, and equivalent weight. If W is given in gram, the equivalent weight should be also given in gram. Therefore, this is the equation. We are going to make use of this. And the problem asked is different from one to another. Here, first we will see the strength of the current and the quantity of the current passed. Strength of the current is the nothing but its amperage. What is the amperage? It is given the symbol for is A, unit symbol is capital A. And the amount of the current passed or amount of the current used is generally Q, and that is given by I into T. And what is I? Ampere. What is T? The time of passage of the current in second. And ampere second, 1 ampere, 1 second is called coulomb. 1 ampere second is called coulomb. Therefore, amount of the current is nothing but, amount of the current is nothing. 1 coulomb of current is passed means, what do you mean by 1 coulomb of current is passed? That is 1 ampere current is passed for 1 second is called 1 coulomb. What is 75 coulomb? What is 75 coulomb? The 75 should be split up into two terms. One is 75 into 1, or 25 into 3, or 15 into 5. It's not. That means 75 ampere current is passed for 1 second, or 25 ampere current is passed for 3 seconds, or 15 ampere current is passed for 5 seconds, or you can take this as a I value and this is the T. Then 1 ampere current is passed for 75 seconds, 3 ampere current is passed for 25 seconds, or 5 ampere current is passed for 15 seconds, and so on. That was 75 coulomb means the quantity of electricity passed. Therefore, whether you are asked to calculate strength of the current or the amount of the current passed, that one. And next thing is, what is F? F is called the Faraday of electricity. What is the Faraday of electricity? That is, during the passage of the current, how many electrons are released and how much amount of coulombs of electricity is required. For example, now let us consider, I will explain this, making use of this one. Sodium metal or sodium ion. For the reduction of the sodium ion, it is in need of 1 electron. For 1 atom, you are in need of 1 electron. For 1 mole of sodium ion, you are in need of 1 mole of electron. Therefore, how the electricity passed by the 1 electron is equal to, that is charge over this equal to 1.6 into 10 power minus 19 coulomb. You might have studied it. For 1 mole of electron, it is 6.023 into 10 to the power of 23 electron equal to how many electricity is passed into 10 power minus 19 into 6.023 into 10 to the power of 23. If you multiply this, you will be getting 496,485. For our calculation, we using as so many coulomb. Therefore, for the reduction of 1 mole of sodium ion, we are in need of 1 mole of electron, that is equivalent to 1 Faraday of electricity, that is equal to 96,500 coulombs of electricity is required, that is equal to Q. So many coulombs would be required. For now, let us consider a calcium ion. For the reduction, it is in need of 2 electrons. Therefore, calcium metal is there. For 1 mole of calcium ion to be reduced, you are need of 2 into Avogadro number. 2 into Avogadro number of electrons. It is just twice the mole of electron. 1 mole of electron for 1 electron species. For 2 electron reduction species, you are in need of 2 mole of electron. And 2 mole of electron would carry 2 Faraday electricities, that is 200 into 96,500 would be required. For aluminium, how many Faraday of electricity required for 1 mole of aluminium to be reduced? Aluminium is giving as aluminium 3 plus 3 electron, giving for 1 ion 3 electrons are required. For 1 mole, 3 moles of electron would be required. 1 mole of electron is carrying 96,500 coulomb, that is nothing but 1 Faraday. For 3 mole of electron, 3 Faraday current is required. This is the way you can see this one. Okay, and this is the Faraday. This Faraday is meant for 1 electron, 1 mole of current, 96,000. And here you are giving equivalent weight. Why you should be equivalent weight? Now we have calculated how much amount of electricity is required for the reduction of 1 mole, that is equal to 1 Faraday of electricity. I want to convert into weight. I want to convert into weight. 1 mole of sodium weight is equal to yacht. I have to multiply it. 1 atomic weight. 1 mole is equal to 1 atomic weight. Therefore, multiply with the atomic weight. You will get the weight in gram. And that is called. And for 2 Faraday of electricity, you have to, for 1 mole, it is equal to 2 into atomic weight. Or instead, if you divide it by 1 Faraday, convert into 1 Faraday, atomic weight divided by 2. This atomic weight divided by 2 is called equivalent weight. What do you mean by equivalent weight? Equivalent weight is defined as, or it can be easily calculated as, equivalent weight of any metal can be calculated as atomic weight by its valency. Or if it's a species, total species, you can calculate as molecular weight by oxidation number change. Oxidation number change. For example, Fe2 plus ion is there. What would be its equivalent weight? Atomic weight of iron, here 2 electrons are required. Oxidation number change is 2 plus 2, 0. 2 atomic weight, 2 oxidation number change divided by 2, you will get the equivalent weight of the iron 2 plus. For iron 3 plus, the equivalent weight is equal to atomic weight by 3. For FeO4 2 minus last, the Latimer diagram we have seen it, the atomic weight is now equal to by 6. and so on. Therefore, in order to is having this one 3 Faraday and 2 Faraday, here we put it is that W is equal to the equivalent weight. Why I have put Q? So far we have seen E means the EMF of the cell. Don't be confused with that. Therefore, I have put it here EQ by 1 Faraday. Therefore, this is nothing but 1 Faraday, how much this is there, if you equal to it is nothing, but you call it as the EZ, EQ, and divided by 965,500, 96,500. That we defined as EZ. EZ is defined as the amount of substance deposited or evolved when 1 coulomb of current is passed. 1 coulomb of current is passed. It is the weight of a substance or the volume of the gas evolved when 1 coulomb of current is passed. What is 1 coulomb of current? 1 ampere current is passed for 1 second. This is that you have already studied. This is derived from the first law of Faraday's law. It is called electrochemical equivalent weight. Electrochemical equivalent weight. This EQ is called just equivalent weight. When you divide it by a Faraday value, it is called, you will get electrochemical equivalent weight. What is electrochemical equivalent weight? The weight of a substance or the volume of the gas evolved for the passage of 1 coulomb of current is called electrochemical equivalent weight. Okay, therefore, now what are the possible questions that can be asked? For the deposition of 0.8 mole of, for the deposition of 0.8 mole or reduction of 0.8 mole of Al3 plus ion requires how many Faraday of currents? How many Faraday of current? This can be, you made use of this equation, this formula, you can make use of this, how many Faraday of current, or directly we can use this. For 1 mole of Al3 plus, how many Faraday of electricity is required? Using this oxidation number, 3 Faraday of electricity is used. 0.8 mole aluminum 3 plus is equal to 3 in F into 0.8. This can be shortly given, but this type of problem would not be asked because this is a basic problems we are going to use, therefore it will not be asked anywhere else except in NEET examination. And instead of mole, you can be given for the passage of 0.8 mole of Faraday, 8 mole, for the passage of 8 Faraday current, how many grams of calcium is deposited? It may be asked. Or so many grams of calcium is to be deposited, how much time you have to pass 10 ampere current? Repeatedly they would be going on asking questions, but all the questions are based upon the formula W is equal to equivalent weight by F into I into T. And before seeing the problem, once again I am going to give you some more relationship. Then it will be helpful to you in solving the problem. Therefore, take down this relationship. 1 Faraday is equal to 96,500 coulomb is equivalent to, that is the current carried by 1 mole of electron. That is equal to this amount of energy is required to deposit 1 gram equivalent weight of a substance, or it is equivalent to the equivalent volume of the gas evolved at STP. The equivalent volume of the gas evolved at STP. equivalent volume, or what is the volume of the gas at STP, that is 1 mole of any substance would be equal to 22.4 liters at STP, standard temperature and pressure. Here volume is depending upon the temperature and pressure. Therefore, we standardize the condition 22.4 liters. And the standard temperature is 25 degree, pressure is 1 atmospheric pressure. And if you have the idea, immediately you can work out what is the substance space is given. Immediately you can easily work out it. For example, now let us consider uh, some specific example, say sodium. Sodium, that is equal to 96,500 coulomb. 1 F is equal to this much. I am going to give the what is its equivalent weight. Then what is this? What is called weight in grams. Then if volume is there, volume in cc, I am going to give for sodium ion. 1 Faraday of sodium ion, what is the charge over the sodium ion? 1 charge. Therefore, for 1 Faraday means 1 mole of electron. 1 mole of electron means atomic weight of 1 mole of electrons equal to equivalent weight. 1 mole of electrons equal to equivalent weight. Sodium ion, how to calculate the equivalent weight? That is atomic weight by valency, or the charge present over this. You can say how many electrons are required for one atom, one electron. That is nothing but the valency. Therefore, equivalent weight is atomic weight is 23, valency is 1. Therefore, 1 Faraday current would deposit 23 gram of sodium. That is equal to 1 equivalent weight or 1 molar. 1 equivalent weight or 1 mole of sodium, because valence 1 means equivalent weight as well as molecular weight are one and the same. Now let us consider a bivalent metal ion magnesium. For one formula weight, 1 Faraday of current, if magnesium is deposited, it is equal to equivalent weight. What is equivalent weight? That is equal to atomic weight by valency or oxidation number. In magnesium, how many charge would be there? Magnesium. Therefore, atomic weight is 24 by 2 equal to 12 gram. That is equal to, in terms of mole, half a mole, because molecular weight divided by 2, half a mole. But in the case of sodium, equivalent weight is equal to 1 mole. If you understand this one, now you work out for fluorine, I'm sorry, iron 2 plus, iron 2 plus, iron the value, let us take 56, the atomic weight. Let us have it. சொல்லுங்க பார்க்கலாம். அதுக்கு first of all, you should find out the atomic weight. Atomic weight வந்து gram of iron would be deposited by 1 Faraday of electricity. In terms of moles, it is equal to half a mole. Now let us assume for aluminium. Aluminium charge is 3 plus. Its atomic weight is 27. Therefore, 1 Faraday of electricity would deposit how many moles of aluminium? That is 1 by 3 moles of aluminium. How many weight? The 27 for 1 mole divided by 3 equal to 9 gram would be deposited. Now, 1 Faraday of current would be evolving oxygen. How much oxygen would be evolved at STP condition? Oxygen is a gas. First of all, you can give in terms of weight, then you can give in terms of the volume. What is the equivalent weight? atomic weight divided by the oxidation number. This oxygen is obtained from O2 minus converted into O2. Therefore, two oxygen. Therefore, atomic weight divided by what? சொல்லுங்க. Atomic weight divided by
4,
how much? Change in the oxidation number. Hello?
4, sir.
Hello? Seri, atomic weight divided by 4 because for one oxygen is O2 minus is 2 or valency of one oxygen atom is 2, 2 oxygen 4 and the molecular weight is 32 by 4. It is equal to 1 by 4 mole equal to 8 and 1 mole of any gas would occupy 22.4 liters. Here equivalent weight 1 by 4 mole equal to 5.6 liters. Equivalent weight is equal to, equivalent volume is equal to 5.6 liters. And for hydrogen, tell me the hydrogen H plus is converted into H2 gas. If hydrogen is evolved, 1 Faraday of the current would evolve the molecular weight by or atomic weight in சொல்ல முடியாது because it is the molecular weight by the change in the oxidation number. For one atom valency is 1, for two atom it is 2. 2 divided by 2 is equal to 1. Therefore, it is equal to half a mole. Okay, in that grams of mole, it is half a mole. And in terms of volume, it is half equivalent volume and equal to half into 22.4 liters equal to 11.2 liters. Therefore, weight is 1 gram is equal to 11.2 liters. These correlations are very, very essential to work out the quantum mechanics. Sorry, not quantum mechanics, it's electrolytic cell equations. And here, what are the types of problems that can be asked for which we will take W equivalent weight by the Faraday into I into T. Equivalent weight for a given substance is a constant. They won't ask this. They won't ask what is the F value. They won't ask this one. Or if at all any weight is given, they may ask how many Faradays of electricity is required. But equivalent weight is a constant for a given species. If W in gram is given, here you should give the equivalent weight in gram. You should give the equivalent weight in gram. Sometimes the hydrogen, etc. is asked hydrogen, they would give in terms of volume. The volume is given. Here the equivalent weight should be given in terms of the volume. One equivalent weight or how much is equal to this. This is the calculation we have already seen. How to calculate the equivalent volume. That is 22.4 for 1 mole of the gas divided by the change in the oxidation number by F into I into T. Sometimes you are asked to calculate how many moles would be formed. If moles are formed, they are not giving what they are not they asking the weight. How many moles are formed or how many equivalents are formed? They would be asking. How many equivalents are formed? W divided by the equivalent weight is nothing but the number of equivalents formed divided by 1 by F into I into once again, they are changing the questions like this. And suitably, you have to work out, they bring this, there are so many equivalents are released. Therefore, W by EQ is they have given. And you put the value, substitute the value here. And of these three, you would be asked something else. Okay. And now I am going to give one problem. And this is making use of one set of equation. They may give for aluminium This aluminium, for this equivalent, so many Faraday of current is required. For calcium, for the same equivalent, how many Faraday of electricity is used? Then you have to use first set, you use this equation. For another set, you should use the same equation. Then one divided by another equation, you will easily get the answer. Okay. Now we will work out the from simple things, then we go for a higher one. Take down the first question. Take down the first question. If 0.2 to 4 liter of hydrogen gas, if 0.2 to 4 liter of hydrogen gas is formed at the cathode of a cell at STP. How much magnesium would be formed at the cathode? How much magnesium would be formed at the cathode of another electrolytic cell for the same amount of current passed? For the same amount of current passed. Here in one cell, hydrogen gas is evolved. What is the current required for that cell? You need not consider, you need not calculate that quantity of electricity passed for the liberation of 0.224 liter. For the same current, how much magnesium would be obtained in another electrolytic cell under the identical condition? Therefore, here you have to make use of two questions. That is, volume of hydrogen is given. Therefore, first thing 0.224 is equal to equivalent weight of hydrogen. You should give in terms of volume. That is, we have already seen hydrogen valency 2, 1 mole equivalent would be the mole divided by the valency, it is equal to 11.2 liters. Therefore, here we place 11.2 liters. Why we have placed it in liters? Here the volume is given in liters. If it is given in ml, you should convert it this also ml. Therefore, look at the value in which unit it is given. Accordingly, you should put. Here you should not give the 1 gram as the equivalent weight because it is given in the liter. Here the equivalent should be weight should be given in the volume, that is 11.2 liters one equivalent weight. I think you understand this conversion first of all. And the second thing, then 5 Faraday. Faraday is 90. You need not to put the Faraday also into I. What the current was, what is the T, that is not necessary. This is the equation 1. And the second is asked, for that current, how much gram of magnesium is added? Let X gram of hydrogen is, X gram of magnesium is liberated. What is the equivalent? EQ is there. Formula is W is equal to EQ by F into IT. EQ, here weight is asked, therefore gram equivalent weight should be given. For magnesium, equivalent weight is equal to atomic weight by 2 because magnesium is in the +2 oxidation state or its valency is 2. It is better go by the oxidation number. Therefore, it is equal to by 2. Therefore, the atomic weight is 24. Therefore, place 12 by F into I into T. This is equation 2. Now, divide one equation by another, either 2 divided by 1, you would get x divided by 0.224 equal to, keep this as such, 12 by f into it, divided it by this one, just invert this, 11.2 into I into t, into F. This F and this F cancel. This and this cancel. And X is equal to 12 into 11.2 into 0.224. Tell me the answer would be greater than 0.224 is not. This answer is greater than point because if you make it in 12, 12 by 12 it is equal to 0.224, but here denominator less than the numerator, therefore it is definitely greater than. And ask your mind what the value you can put here. Anybody ask your mind, otherwise you should go by our calculation. By which method? 1.2 into 2.24 into 10 power minus 1. I'm sorry, 2.2 divided by 1.1 into 10 power 1. This 1.1 and this would be cancelled in the 2. It is equal to 2.4. Okay. Bring this 10 power 1 upper side. 10 power minus 2 minus 1. Here 1.2 that we have left it 10 power 1. This and this cancel and bring it about 10 power minus 1. Therefore answer is 0.24. For this lengthier process, ask your mind what would be the very nearest answer. Your mind will say 0.23 sir, adding, or 0.235 or 0.24 sometime. Therefore, which is the correct answer? That answer which is nearer to 0.3 would be the correct answer. You can easily work out this one. And this is the formula. Similar formula I am going to give you. Take down this one. If the cost of electricity, for producing X gram of aluminium, X gram of aluminium is rupees Z. Rupees Z rupees is required. What is the cost of electricity producing X gram of magnesium? X gram of magnesium under the identical condition. Identical condition means that is the current efficiency, temperature, pressure, etc. It is called identical condition. And the current efficiency is I have omitted in the equation. I will, after working out this problem, I will tell you what do you mean by current efficiency. A, 9 is Z, B, 12 is Z, C, 9 by 12 is Z, and D, 12 by 9 is Z. How to work out this? Yes, it can be worked out. And for which, once again, the weight deposited is equal to equivalent by F into IT. This I and T, it is the quantity of electricity that is produced. For that I and T, which is asked, EZ is you have paid the EZ. Therefore, you can put this INT instead of INT, EZ rupees has been paid. Okay. And here the weight is equal to X gram. What is the equivalent weight for aluminium? Aluminium is equal to 27 atomic weight, valency 3, therefore 9 by F. In the place of the quantity of electricity produced, I have put EZ, so much amount of electricity is produced. Then this is the one equation. They are asking another equation. What is the equation asked? For the X production of X gram of this one, the 9 by F, sorry, I have Sorry, pa. Excuse me, not put a Z here. Put it I into T or Q1. Let us assume the quantity of electricity used is Q1. Okay. Then 9 by for the next one is magnesium. For magnesium, 9 into Q1. Okay. For magnesium, we have to write down the second equation for the same amount, x gram. What is the equivalent weight? 12 equal and Faraday F and Q2 is the current that is required. We are going to calculate Q2. Therefore, we are now divide 1 by another things, equation 1 by 2 or anything. You can put is this we will be giving x by x would giving 1 is equal to 9 by 12 into Q1 by Q2. Therefore, Q2 is equal to 9 by 12 Q1. Q1 is the electricity per tube required for the production of the X gram of aluminum, for which they have spent Z rupees. Therefore, for Q2, you have to spend 9 by 12 Z. Therefore, correct answer is this much. In this way, you can calculate this type of problem. And another type of problem, take down the question on electrolysis. On electrolysis of acidified water, the volume of hydrogen liberated, is 5.6 centimeter cube. That is, they have given in terms of ml. What is the volume of oxygen liberated? What is the volume of oxygen liberated? In the same vessel. Once again, you have to make use of the standard formula. Here, volume is given. Therefore, right is volume and equivalent weight. Here also, it should be given in volume by F into I into T. Volume 5.6 cc, 6 ml. Therefore, what is the equivalent weight of hydrogen? Equivalent volume of the hydrogen, for which we have already seen it is 11.2 liters or 11.2 liters. 3 so many ml vandiruma divided by Faraday into I into T. Okay. For the in the same vessel, how much volume is liberated? Say V volume is liberated. For oxygen, equivalent weight in terms of volume, we have calculated it as 5.6 into 10 power 3 ml. By F, the same quantity of electricity is passed I into T. This is equation 1. This is equation 2. Now you can work out the V, it is a upper, to bring it upper, divide 2 by 1, you will get V by 5.6 is equal to 5.6 into 10 power 3. Or here itself you can easily calculate this. Therefore, 5.6 divided by 11.2. Therefore, V is equal to 5.6 into 5.6 divided by 11.2. This and this 2, this would be equal to 2.8 centimeter cube. 2.8 centimeter cube. I think you understand this one. Sir, is there any shortcut method is there? Yes, it is definitely there is a shortcut method. The same is there. Two equivalents, that is hydrogen. How many equivalents? This hydrogen, it is called obtained from H plus and H plus 2 valency. For 2 valency, it is 5.6 ml is liberated. For oxygen, 4 valency, totally 4 valency. 5.6 into 2 divided by 4 divided 2, 5.6 divided by 2.8 centimeter cube. You can also go by this method also. By which method you are making use of it? By equivalent method, 11.2 liter of hydrogen is equivalent to 5.6 liter of oxygen for the same current, and 5.6 into here liter you have to put 10 power minus 3 liter of hydrogen. How much oxygen is there? X. Find out X. Find out X. It can be easily done. Okay. Once again, if you multiply this 5.6 into 5.6 divided by 11.2, you will get the same answer. This is the another method by which you can also calculate this. The last question for this session and the remaining question we will see in the next session. The last question, take down this. How many Faraday is required? How many Faraday is required for the reduction of point not 5 molar permanganate ion. And if any problem is stopped at this stage, it is not possible for us to work out because permanganate ion is undergoing reduction. To which species is undergoing reduction? If for the reduction of magnesium 2 plus, if it is asked, you can say that it will be converted into magnesium. The zero oxidation state is a definite one because intermediate oxidation state is not there. But permanganate ion, we have already seen the lateral diagram in the plus 6 state, in the plus 4 state, in the plus 2 state, or 0 state, to which oxidation state is undergoing reduction. It should be mentioned. Therefore, point, which mole? Point not 8 molar. What I have given for the reduction of?
0.05.
Hello?
Not 5. Point not 5.
Hello? Nobody else there?
Sir, கேக்குதா?
சரி பார்த்துக்கோங்க பாயிண்ட் ஒருத்தருமே இல்லையா
சார் நீங்க பேசுறது
Point not 5.
நாட் எயிட்னு வச்சுக்கோங்க MnO42 MnO2. And for this, you have to find out what is the change in the oxidation number. It is in the plus 4 state. Manganese in the plus 4 state. Here manganese in the plus 3 state. Change in the oxidation number is 3. Therefore, for the reduction of 1 mole of MnO4 minus, how many Faraday is required? 3 Faraday is required. 0.08 mole of permanganate. We are in need of 3 into 0.08. This is equal to 0.24 Faraday and so on.